Well, good morning. I'm here to make 2 points to you. One is that this is one of the most exciting times in your lives, both being a graduate student, which I very much loved. I got my PhD in philosophy and cognitive science, so modeling. Nothing on energy, though, which shows you that you can change careers later. Second, though, that this is as transformative a time in the energy space as we've ever seen. You've seen some of the data already. I'm sure lots of you have already studied pieces of this. There's just so much technology change, business model change. And I will show you that actually those changes, and this is my second point, we ought to do them just for the benefit and health of the economy and the society we live in, not only because carbon pollution and local environmental pollution actually is a really urgent problem. Most people think we're making these changes only because of carbon pollution, but I'm going to make a case to you that actually they work and should be driven by economic fundamentals as well as a moral imperative to solve carbon. I want you to close your eyes and think about 4 generations back, your great-great-grandparents. Think about their life and what their energy looked like. Probably they looked something like this. This is a set of immigrants to Ellis Island. And if you think about what they had, most of them grew up and died within the same town, unless you were an immigrant to Ellis Island. Then you took this once-in-a-lifetime boat voyage. They also were typically pretty close to the minimum nutrition requirements. They died about 10 years from the age you are now. Most people lived into their early to mid-30s. They didn't have electricity. They didn't have running water. Their day ended when daylight ended. And they obviously didn't have machinery. Everything was human-powered, sweat and labor, and a little bit of animal work. I want to fast forward to New York. Picture New York a little over 100 years ago in the 1870s. We would have just had the first railroads connecting New York to the rest of the country. You can see in the picture they're the first steamships, so we're no longer just all animal power. And you can see a bridge, a very famous bridge. Actually, when it was designed, it was the first bridge ever to use steel. And there were papers written at the time of how this was a very risky, structurally uncertain, very dubious material, very sketchy to be used for anything in architecture. So within the space from 1860 roughly, in this picture, the change is already beginning, to 1920, New York transformed. You can see not only skyscrapers, the tallest building in the world at that time, the Empire State Building, still missing its antenna there in the background of the picture. You can see much more steam power. You can see factories in New York, which are mostly gone today if you visited New York today. But at that time, an industrial powerhouse. And suddenly we have transport in the 1920s by internal combustion engine. We have rail that literally takes the time to go transcontinent to a matter of days from months that you had to travel before. Trade beyond 150 miles overland becomes possible, no longer just all sea trade. And we have these buildings that are energy efficient, that have lighting, that actually don't burn, the way that a lot of the buildings in New York did before this period. And suddenly we have modern conveniences. We have air conditioning, you can refrigerate food, you can drive into the suburbs, the cities begin to spread out. So life has radically changed in a period of about 40 years. We talk about the Industrial Revolution a lot, which is a century earlier, but this is really the period where sort of everyday life and quality of life changed. Most important thing is life expectancy doubles, and this is before the advent of penicillin and most of the antibiotics and modern medicine as we know it. This is just from sanitary conditions. So we've gone through this change, and we think we're done, right? There's famous economists who are writing, we're sort of at the end of innovation. Now it's all about Twitter and Facebook and online apps, but it's really not changing the infrastructure anymore. I want to make a case that our infrastructure today is horribly unproductive and horribly inefficient, and that actually is an economic opportunity to do this again in your lifetime, right here, right now. How many of you own a car? Okay, where's your car? Parked? Parked? Anybody who owned a car, keep your hand up. What kind of car do you have?
1994 Toyota Camry.
Excellent. You like it?
Yes.
Very efficient. Good. But it's parked. How much of the time do you think your car's parked?
95%.
95. Yeah, actually very close. 96% for average for Americans. Unless you're a Tesla owner, then you actually drive it 10% more. I guess it's... So you made your car purchase. How many of you own a house? Okay, a few of you. If you don't own a house, the car was probably the single largest purchase you ever made and will make until you're ready to go buy a house, or maybe some of you will one day buy a jet or a yacht. That asset is getting 4% utilization. If you were to go to a bank and say, I want to make an investment and I want to get a return of only 4% utilization on my asset, and the rest of the time it's sitting idle. In fact, most of the time you're actually paying to park, certainly here on campus, right? So it's losing money. That would be horrible. And I want to show you that that's only one example in which our current transport infrastructure is hideously inefficient. So you've seen the parking there, and by the way, of the 4% that you're in it, you're actually looking for parking or stuck in congestion most of the time. So not a wonderful experience. The second, and this goes back to an analysis Amory Lovins did in the 70s already, so you can imagine how long this has been the case. Most of the gasoline we put in at $3, $4 a gallon actually turns into heat and waste and brake wear and other things you have to pay for. So only 1% actually goes to moving you from A to B. What a horribly inefficient way to move about, right? The horse and actually walking are all much more efficient. On top of that, we accept that this is one of the top 10 causes of death in the country. 33,000 people die every year, $300 billion in economic damage in terms of lost work, repairs, and destruction, and suffering. And then we get to the worst part of all, our roads. Roads are at peak utilization. You can see up there 5% of the time. Basically, it's the rush hour time in one direction. Here in the Bay Area, we tend to get rush hour in both directions, but that's a little unusual for the rest of the country. And then at that point, at peak throughput, you get about 1,900 cars per lane per mile. That's the maximum throughput you could put on a road. If you put more cars on, you get the sort of Beijing-style traffic jam that take weeks to resolve. So we actually have 0.1, if you do the math on that, we have 0.1% utilization in the best case for our roads. And by the way, we pave about 1% of our country. It's much more than that in cities. And we spend about 1.7% of our GDP on building and maintaining our roads. So this is a huge investment in the same order of magnitude as healthcare or other big investments in the economy. It doesn't have to be this way. And let me show you this as an illustration. And this is all stuff that is already happening now. It's just not been put together the way I'm showing it to you here. And that's the opportunity for you in your graduate careers and in what you continue to do on beyond that to actually make this happen at the system level. First of all, the cars can be connected, and I call it ACES just because it's a cool way to remember all the different pieces. But connected means we can actually have Google Maps automatically drive our routing, right, and work around congestion. We can also, there's a company called Urban Engines that looks at actually shifting when you drive, because it turns out that 101 isn't always congested. Even during rush hour, there are actually pockets of empty space in which you can drive quite quickly. So if only you knew, you could be on the road at the right time. We can electrify, which takes us from horrible efficiency to roughly 85% for the battery plus electric motor combination of the drivetrain, and more aerodynamic cars because you can change the configuration. We can share them, as we're beginning to do with Uber and Lyft, but actually I would argue that's only the first generation. And this is where we hit that lever that I talked about, right? We go from 4% utilization, average, 15% utilization at peak and rush hour, which means 85% of cars are still parked even at the height of rush hour. 85% are still parked. We can go to about 60, 65% utilization. Nobody wants the 2 a.m. to 4 a.m. slot typically. So we're never going to get to 100%, but we can get much better than we are. If we put them all together, we can also begin to make the cars be autonomous, which means all the mismatched trips can actually be matched. Like airplanes, which we no longer fly manually, we fly on autopilots, we can reduce about 90% of all the accidents. So we save 30,000 lives out of the 33,000 deaths that we have. And the problems with each of these elements alone actually get better. If I share the car, the high upfront cost of the battery actually matters much less. If I have autonomy, the car can go recharge itself while I don't need it on its own. The question of how much charging infrastructure we need to build is much, much simpler if actually cars can schedule themselves through the charging infrastructure rather than me hogging that one electric parking space that's in the building all day. So this shows you, and the aggregate impact is huge. It's about $1 to drive an SUV today. You can see up there it's 67 cents if you're driving your Toyota Camry. Probably a little bit less if it's an older model. But if we do this, we get to below 10 cents a mile. So this not only means that transport for the entire economy has become cheaper, which has a massive, as a platform technology, has a massive knock-on effect to the rest of the economy, but it also means that people who previously didn't have access to driving, who couldn't get a job because they can't make it across town because they're reliant on public transportation, or people who are blind or too young and trying to get to their soccer practice, or people who are too old or disabled and can no longer drive, can suddenly participate in the economy. And by the way, this is just the car part of the vision. We can actually integrate this with transit, which is much, much cheaper in terms of per passenger mile cost. And so that you can actually go from one town to another, but have the full access that cars afford you today, and you don't have to make a trade-off between is it convenient or is it efficient and fast. So I'll give you a couple more illustrations briefly of this already happening. Dan already showed you data on the cost reduction, then he showed you competitiveness of different generation technologies today. I'm going to put those two together and basically show you what competitiveness looks like in the future. I'll call your attention to some things that are not broadly talked about in the dialogue about this. Look at these lines. These are nuclear and coal plants. You notice they have negative learning curves. They're going up in cost. In the case of nuclear plants, ever since the plant number 3. In the case of coal plants, since 1967. So they have been getting more expensive, not less. Most of that's because the technology is mature. The technology cost reduction and the learning curve effect is very small. And so commodity prices and other safety elements that we've added on have basically added to the cost over time. By contrast, as most of you will know, wind and solar are on these very steep learning curves improving. And you can see, depending on the geography, crossover points are either already here or relatively close, basically in the next decade. And you can see that ultimately, particularly for developing countries, one of you asked the question, why should developing countries bear part of this burden when the responsibility morally for all the carbon emissions really is the developed world? They should do this for economic reasons, because in fact, it's cheaper to power your economy with solar and wind a couple years from now than it is to do so with coal plants. That is not even including the very real social costs of building coal plants in terms of air pollution, as you see in China, and in terms of death from asthma and other cancers from the air pollution. So another one that doesn't get much attention, how much stuff we consume. Each and every one of us is responsible for 86 metric tons per year of our life. Most of that is stuff that doesn't cross your door threshold because you don't see it. It's somewhere upstream in the supply chain, right? Somebody mined a whole bunch of rock for you to make the metal that winds up making the beautiful aluminum shell of your iPhone. So you don't see it, or it goes into the aggregate that's in the roads that we take for granted because the government builds it. But that is a huge amount of material, and the vast majority of that is once through. We don't reuse it. We have to dig it up and reprocess it every single year. Again, it doesn't have to be this way, and I'll show you just one example, but you can do this in any industry. Somebody mentioned Boeing's factory, right? Boeing has gone to recycling almost all of its titanium, which is now a big component for planes. But the single largest place where we put stuff is in this, physical infrastructure in the form of buildings. And for buildings, when you build a building, 30% of what you bring to the building site winds up in waste before the building's even built. And most of the landfill that we have for municipalities actually is construction and demolition waste from tearing down old buildings. So this is the #1 driver of wasted material that you would typically see. This is a company up in Calgary called Doing It Right This Time that basically reinvented buildings to do in buildings what we've done in automotive assembly, what the Venetian Navy did to defeat all the other navies in 1400. We made them modular, and we made it interchangeable parts so that you could actually substitute from one to another, or you can reconfigure the building because it's all standardized. They invented these little connectors that are extruded aluminum that take the place of nails, screws, and other fasteners that typically are destructive to materials, right? If I drive a screw into a piece of wood, that piece of wood is forever changed. It's not a reversible process. These slide in and lock, and then can be taken out exactly the same way. They've done this to build hospitals this way, where you can actually reconfigure a hospital wing in a day or two without shutting it down because there's no sawing, no drywall dust. All of these components are factory built, drop shipped to the site in 2 to 3 weeks. It made it zero waste in the factory, by the way, because everything is cut exactly to the sizes and lengths that you need, and the parts, like the little bits of insulation that trimmed off, actually go back to the manufacturer and get turned into new insulation. And then they can install it. And installation is, as I mentioned, a couple days. This is a living room you can see. You can build in your high-end TV. All of the wiring, all of the plumbing, in the case of the hospital, all of the gas lines and medical equipment is already built in at the factory, and so is designed in from the beginning. If you move, and a lot of the high-end companies, Google, big banks are now using this, if you move 85% of all your interior design can actually be adjusted to the new space. You typically do have to buy a few extra parts, but most of it will move with you, and you can just reconfigure it into the new shape of the new space. All of this is possible in part, by the way, not just from design innovation, but IT. They have a system called ICE that is basically the software that automatically in real time lays out the interior and tells you exactly at each moment what the price is, so you can also make trade-offs. I can see that driving was more interesting to you than buildings, because most of you are not as attentive on this round. It'll get to the point when you build a house and you realize that your marriage is in trouble because you're remodeling a house, that you will actually care about this stuff. But that's to come. I want to show you a quick video of what this means in practice. This is a skyscraper in China. If you could run it. Can you do it on here? Okay. There we go. This is the same principles. Factory built, put on a pallet that is basically a floor panel. All of the vertical wall elements already contain all of the wiring, plumbing. It's super energy efficient. All the insulation's built in, the latest thermostats, control technologies. It's earthquake safe, because in China has the same issues as here. And those of you who have been paying attention closely will be able to tell that in 15 day-night cycles, this entire building got built and finished. And because it's modular, if anybody wanted to, which isn't going to happen in China probably given the demand growth, but you could actually take parts or all of this building down, move it somewhere else, and reassemble it in the new place. So this is the same principles applied on a much larger scale for construction. And by the way, if you want to see one that has some elements of this, not all of these, the new spaceship that Apple's building in Cupertino has a lot of these same principles of prefab concrete, centrally built in a plant, and then installed very quickly on site. They're taking a little bit longer than 15 days to build it, but that's because I'm sure they're putting other stuff into it. If you look at the economics of this, it's basically trying to do the same thing that we saw with the cars, right? You're making them more efficient, you're making them modular, reusable, you're making them integrated between the different systems. A lot of our buildings in the US, the security system, the climate system, the fire control system, all don't talk to each other, even though they're basically doing the same thing, right? Where are the bodies, where are the humans, when you need to know where they are. And then ultimately adding in the new lighting technologies and new air conditioning technologies that make each of the subsystems more efficient. Why do I think this is so exciting? Other than there's a whole bunch of really cool technology that all of you are probably going to work on over the next couple of years here. But it affects our lives. Most of you probably don't have most of this stuff anymore. When I was a consultant for McKinsey, I carried all this kind of stuff around in my bag. And now it's this, right? There's an app for that. That may be convenient, which is great, but it's also resource efficient because it's about 1/100th of the energy content to download your music or read your book through an iPad, even counting all of the data center and broadband connection and all that stuff that it takes to get it to your phone, rather than shipping it as a traditional product with a jewel case or with a bound set of paper that you actually consume and then ultimately, probably most likely recycle or throw out. So this is a dramatic step change in the economy to actually go digital, and this is only the beginning because we can actually do healthcare, we can do large parts of education, we can do most of our government interactions in these set of principles as well. It doesn't have to be 1040 paper forms that you mail in to the government, right? It doesn't have to work that way. So we're at the beginning of that change. My last slide then, to show you the principles of this, is not only will we make it more environmental, lower carbon, but actually we want to make it better. We want to make it surprise and delight customers, as most of the consumer brands would say. If you talk to Procter & Gamble, that's what they are trying to do with their products. It needs to be more convenient and compatible with the infrastructure. No utopian scenarios of we're all going to live in Disneyland with monorail cars that take us everywhere, right? That's not going to work. We can't get there from here. And it has to be scalable and cheaper. And yes, cheaper is a central part of this because that's how we get the economy to be more productive. And I'll show you just what this means in terms of cheaper. This is some relatively crude math. If you scale all these technologies that I've described, the average household basically gets 30% additional income. That's the stuff we don't spend on energy, on transport costs, on repairing our car, on buying a new car all the time when really we could be getting much higher use out of the existing assets, and on shifting to services and making our homes more efficient. If you're living on $50K as a family and you get $15,000 extra per year, that's a pretty big impact on your family. Now, we might all spend it on TiVo and blow it that way, but that's up to each individual. TiVo, by the way, is now the single highest consumption energy device in most homes because the refrigerators all got less energy intensive, as Dan described earlier. So with that, over to you for questions. Yes. Carol.
The energy capture and collaborative and Cassie's class.
I forgot that was actually the last slide, but that's not part of the talk. Kathy Zoe, who's former Undersecretary of Energy, and I have been putting together a program to basically run solution-centered work here at Stanford. We're starting with a series of courses focused on two themes, one on transport and the second one on the energy distribution grid. You're welcome to take either one or both. They will ultimately run as a series throughout the year. We'll start with looking at what are some of these solutions, what are their economics, what are the barriers to scaling. We'll have companies involved to actually help translate them in the winter quarter into pilots so that we will actually go try these things in practice, whether it's a new app or a new transportation algorithm or a pilot to actually integrate solar and storage in a particular facility and manage them together and manage demand at the same time so that you can begin to real-time balance a grid. And then ultimately, in the spring, the idea is to get them to turn into projects that that set of companies or government regulators take forward and implement at larger scale with a vision that any of you who want to work on that in the spring or in the summer as an internship can continue to participate. So we're starting in 3 weeks, I guess. And again, welcome, reach out to either me or Kathy if you're interested in either one of these.
We have flyers on these courses in the registration.
Yes.
So what role does planned obsolescence, and I'm really excited about all this, but what role does planned obsolescence play? You mentioned iPhone, but we were trying to decide whether to buy a tablet or not, and we're doing, throughout my work, like 10,000 pages of paper that go into making one iPhone. It's something. Obviously Apple's not going to make as much money if they don't make you buy a new phone every 2 years, or a new electric car, etc. How do you use that system in a single economy?
Yeah, so one of the areas that is really important here that I didn't talk about is the whole notion of circularity, right? That you either upgrade devices so you can use them for much longer, and this is happening in the industrial domain. A lot of construction machinery, a lot of factory equipment actually is being upgraded this way. You go into a lot of plants, it's a 30-year-old machine but with new software, right? And that's clearly a part of it. In some ways, Apple is doing that, right? The fact that you get all your iOS upgrades for free and they're adding new functionality basically extends the life. Of course, for coolness factors, people still want the latest phone, right? We're all going to go out and order iPhone 6s tomorrow, even though they won't actually change that much over the 5S. But in the long run, there is a behavioral and a consumer awareness piece that I think is central, right? We're not going to attack all of the 86 tons just by making the production processes more efficient. We actually do need to make the products live longer, or we need to reuse them, or we need to at least be able to reprocess them so that you remanufacture them. Caterpillar, for example, is doing that with tractors and excavation equipment, where they actually take most of the machinery and reuse it in a new machine and re-engineer certain parts. So at most airplanes now, actually the turbine blades that are the safety critical component in the compressors are actually being remanufactured and new materials being added to them. But we're not used to that in the consumer realm as much yet, and I agree, that's a change that needs to happen gradually. And part of that is awareness, part of that's going to be convenience. Today it's not very convenient to actually remanufacture, so we need reverse logistics change, and we need a way to make sure that that's also valid. A lot of people in the US have the objection of, oh, if it's been used, then it's not a new product, sort of almost a legal definition. And again, that's another change that needs to happen. Yeah. Yes?
What do you see as the biggest obstacle to realizing the vision?
There are a bunch. I think one Dan Reicher already talked about, which is a lot of these new technologies need financing to get deployed. So I agree with that piece of what he described. That is one of the big challenges. The second is regulation. And I don't mean regulation the way people normally think. Most people say, oh, we need huge subsidies to fund all this stuff because, the market won't drive it by itself. In fact, if you look, what we really need is to get rid of the existing subsidies to the traditional fossil-intensive way of doing things. And even more importantly, we need to remove the barriers in our existing regulations and code that inhibit the new technologies, right? Most of you are probably aware that Uber is in this massive fight with taxi commissions all over the world, and the entire country of Germany earlier this week decided they don't want Uber. That is basically legacy business systems and legacy regulations standing in the way of these new business models. Or New York regulations that say you can't use Airbnb to share your apartment, even though real estate is ridiculously expensive, and most people only need a room, they don't need a whole apartment all the time. All right. So there's a lot of work to do, and if you look at fuel standards, they're written based on the kind of oil that came out of the ground 100 years ago. Has nothing to do with how we synthesize biofuels or with natural gas to liquids, or any other new technology that might come along. So we need a lot of change. The vision of automobiles that I talked about, the number one barrier is not technical. The number one barrier is the current insurance industry, right? You are insured for you as a driver. If the car drives autonomously, who's the driver? Is it Google that's responsible? Is it the software engineer who wrote the code? All of that needs to get worked out. And that's a big issue that will take a long time, longer actually than the technical integration of those pieces. So that's not an exhaustive list by any means, but those are the ones that I think are most important to me in terms of changes. By the way, the one we talked about just a moment ago of consumer preferences and adjustments is a big deal as well, right? Most German drivers still don't like taking orders from their GPS system telling them how to navigate around. So, yes, somebody here in the middle had a hand up. Last question.
You showed one slide that compared energy efficiency in traditional automobiles compared to electric, and it was something like 185%. How does that figure change when you include the efficiency cost of generating that?
Yeah, so it does change. If you go on Tesla's website, they have a great map of what the net efficiency is of shifting to a Tesla for different regions of the country. If you're in Ohio, which is one of the highest coal intensity grids, from an emissions point of view, you're still performing better than if you were driving a gasoline car, but it's only marginally better. Whereas here in California, where our grid is pretty clean, we have a lot of renewables, geothermal resources, nuclear, you're way better off. So that number was just talking about the shift in the throughput of from an energy point of view. If you look at then the emissions point of view, that also depends on what your generation sources are. And yes, in the long run, we need to have both of these changes happen in parallel to really get the full benefit. By the way, again, just like I described in this sort of system view, there are positive feedback loops and interactions between having a big electrified car fleet and having a renewable power grid, because the vehicles can actually be the storage that balances your short-term issues in terms of intermittency of renewables and balances the load across a broader area. So you could take Hawaii and turn the rental car fleet into electric vehicles because they don't go anywhere off island, right? And actually that would be the balancing that would get you past 15% solar, which is where the state's stuck right now, because otherwise you do get distribution load asymmetries and overloading of certain circuits and voltage drop in others. So again, by looking at this as a broader system and innovating at the system level, we can make 1 + 1 is 10 rather than just having to solve each problem separately. But your basic point is true, that the full benefit of that does require your upstream piece to also evolve.
Okay, let's thank Stefan again.